Okay, all right, so you're welcome to class today. This is teacher Olumide once again. So we have something we want to derive. We've been asked to derive the quadratic formula, which by the time we are done with the derivation, it's going to be clear to everyone how to do this. So generally, quadratic equation is usually given to be ax squared plus bx plus c equals to 0. So this is the generic way we represent quadratic equation generally. All right, so if we want to derive the quadratic formula, what we mean is we want to be able to make x the subject of the relation. All right, so that's what we are going to be doing in this question. We want to make x the subject of the relation. Now, the method we are going to use to get this is what we call the completing the square method. The completing the square method. All right, so that means in doing this, we are going to be showing how to use completing the square method. So the first thing is, if you look at this equation here, there is a coefficient beside x squared. So the first thing you always want to ensure whenever you are using completing the square method is that the coefficient of your x squared must be 1. Now, if the coefficient of x squared here is a, that means to eliminate this a, you have to divide it by a. By the time you divide it, the a disappears. So what we can do is to say divide through. So we divide through by a. Don't forget the reason why we are dividing through by a, because the coefficient of x squared here is a. So by the time we divide through by a, so we have ax squared over a plus bx over a plus c over a equals to 0 over a. Now by the time you have this, it means a cancels a, so you have x squared plus bx over a plus c over a equals to 0. All right, so the moment you are done with this first step in using completing the square method, the next thing to do is you are going to take the constant side to the right hand side. So if you notice from this left hand side of the equation, the constant side is c over a. C over a. That's the part that doesn't carry x, the function x. So we take it to the other side. That means we are going to have x squared plus bx over a equals positive c over a. If it goes to the other side, it becomes negative c over a. So from here now, we want to follow the next method, which is we are going to divide the coefficient of x by 2. You divide by 2, you square it, you square the result and add it to both sides of the equation. So it's very easy. I'm just outlining this step so that it becomes easier for us to always remember. So the first thing to say is, if they say we should divide the coefficient of x by 2. So what is the coefficient of x in this question? Now you note that coefficient means, if I say what's the coefficient of x, it means if I remove x, what is going to be left? So in this scenario, if I remove x, I'm going to be left with b over a. So the coefficient of x is b over a. So we've been asked to divide it by 2. We were asked to square it, and we are obviously going to be adding it to both sides of the equation. So let's divide it by 2. That means this is going to give me b over a times 1 over 2 all squared. So from here now, if you are going to follow what to do, the numerators are going to multiply each other, which is b times 1, and that's going to be b over a times 2, that's 2a, all raised to the power of 2. So that means this is what I'm going to add to both sides of this particular equation. So that means I'm now going to have x squared plus bx over a plus b over 2a all squared equals to negative c over a plus b over 2a all squared. Now, what we are going to do is this left-hand side, we are going to factorize it, but we'll do that much later. So let's just keep repeating what we have. So we have x squared plus bx over a plus b over 2a. Now, don't expand this bracket. Just leave it the way it is. Negative c over a plus, if we expand this, b squared is going to give us b squared, obviously. Then 2a squared. 2a squared means 2a times 2a. It means we should multiply it twice. So 2 times 2 is 4. A times a is a squared. So that means this will be 4a squared. Now from this side now, you can see that this is still going to be x squared plus bx over a plus b over 2a all squared equals, the LCM here is going to be 4a squared, because a can go in 4a squared. So a in 4a squared, that's going to give us 4a. So what we mean by a, so that's divided by a cancels, so we are left with 4a. 4a times negative c is going to give us negative 4ac plus 4a squared in 4a squared, that's 1 times b squared is b squared. Now the next thing we want to do is we want to factorize this left hand side of the equation, because if you look at this, this is quadratic. But the very easiest way to always factorize it is, if you look at the results when we divided by 2, this was what we got when we divided by 2. We got b over 2a. So what that means is, anytime you are factorizing the left hand side, since we are dealing with a function of x, your answer is always going to be x, the function you are dealing with, combined with whatever you get as the result when you divided by 2. So when we divided by 2, we got b over 2a. So that's positive. So it's going to be x plus b over 2a raised to the power of 2. So what this means is, if I should open up this bracket, I'm going to invariably get this last expression. So we've been able to successfully factorize this left hand side to give us this equals, now this numerator that I have here, if I have negative 2 plus 3, it is the same thing as saying 3 minus 2. So what it means is, I've just rearranged it. The positive 3, I've written it first without necessarily writing the positive sign. Not necessary. Then the negative 2 is coming second. So this one, we are going to do the same thing. We have b squared minus 4ac all over 4a squared. Now don't forget the aim. We want to make x the subject of the relation. Now there is a square. So what we do next to remove the square is to take the square root of both sides, which will mean we are going to have something like this. X plus b over 2a all squared equals to square root b squared minus 4ac all over 4a squared. So the square is going to cancel the square root. Now this guy here is the same as this, square root of b squared minus 4ac over square root of 4a squared. And this again is the same as this, square root of b squared minus 4ac over square root of 4 times square root of a squared. So I'm just splitting it so that it becomes easier for us to comprehend. Now from this side now we have x plus b over 2a equals, so what I have left here is the square root of b squared minus 4ac over, now the square root of 4 is 2. Now don't forget, the normal method that is to say that the square root of 4 is both positive and negative 2, because if you multiply positive 2 twice, you're going to get 4. If you multiply negative 2 twice, you're still going to get 4. So that means we introduce a plus or minus sign here. Now a squared, now this square cancels the square root, we are left with 2a. All right, so from here now, that means we can now say we have x equals, if this goes to the right hand side, it becomes minus b over 2a plus or minus square root of b squared minus 4ac over 2a. And finally, we can then say that this, finding the LCM, you can say x equals, the LCM is going to be 2a into a, that's 1 times negative b, we give you negative b, plus or minus 2a into a, that's 1 times this, that gives you b squared minus 4ac. So this is generally referred to as the quadratic formula, or some call it almighty formula. And the reason why it is called almighty formula is just basically we can use it to solve every quadratic kind of question. You know, we have different ways we can solve quadratic. We can use factorization, we can use completing the square, we can use the formula method, and we can also use graphical. So what quadratic formula denotes is that it can solve any of those kind of questions which others cannot. So I hope you enjoyed and followed through the process. Thank you for joining. God bless you.